Okay, so here we're going to take a look at graphing parametric curves by plotting points. Now, this won't be in practice. Most of our curves will be just kind of hard to just capture by plotting points, but it is beneficial just to at least some basic curves to kind of understand the orientation of how to determine like orientation of these curves, right? So for example, let's say my goal was to graph, and I will do this by hand. In the next video, we'll look at using Desmos kind of to help us graph, right? Something that is more complex, right? But let's say I wanted to graph x of t equals to 2 sine of t, and then y of t equals to 2 cosine t. Right now right away when I see this, right, I have sine, cosine, and then the same coefficient for both of them. Even though in a previous video I associated x with cosine and y with sine, that doesn't change the general shape, right? This, even regardless, as long as one of them's sine, one of them's cosine, and they have the same coefficient, we have a circle centered at the origin, right? In this case, the circle is of radius 2, right? So we have here a circle where the radius is 2. Now, I'm going to plot points to identify the orientation. All right, so I'll set up a chart here, t, x of t, y of t. All right, and here I'm going to check my quadrantal values here. So when t is 0, when t is pi over 2, and t is pi. And this should give me enough information here, right? So when t is 0, right, when I plug in 0, I get 0 for x, right? Sine of 0 is 0. And then when I plug in 0 for y, cosine of 0 is 1, times 2 gives me 2. All right, so we start at the point 0, 2. So we start up here. All right, and then as t goes from 0 to pi over 2, right? At pi over 2, sine is 1, right? Plugging in for x, so we get 2. But then cosine, excuse me, let's see, is that right? Cosine, yes, cosine of pi over 2 is 0, so 2 times 0 is 0. So notice here that we are now down here, right? Now it's important to realize what is happening here, right? When we go from 0, I start up here, and then as I progress, t progresses to pi over 2, excuse me, it goes down in that direction. Okay, so we see the orientation now is much different than the previous formulation. Now at pi here, that should just to confirm kind of what's going on here. Sine of pi is 0, so times 2 is still 0. And then when I plug in the y, cosine of pi is -1 times 2 is -2. So that leads me to the point 0, -2, which is down here. And as we can see what's happening here, we do indeed have a circle with an orientation that is clockwise. Right? So we can see what effect that has when we switch up the sine and the cosine from what we're used to, right? Or for what we standardize, I guess you could say. Now notice here, it doesn't change the shape. All it does is it changes the orientation. Okay, so now let's take a look at one more here. So let's say I wanted to graph so x of t equals to t squared, and then y of t is equal to 2t minus 1. Okay, and let's say this wanted to get done without a calculator, right? Just to kind of get figure out how to do something like this, right? Now my approach here would be first I want to find what the shape of this graph. I'm guessing it might be a parabola, again just from looking at it, but let's kind of confirm that, right? So let's write an equation of this by solving one of the equations for t. I'm going to choose y to solve for, right? So I'll have y is equal to 2t minus 1. So I'll add 1 to both sides. Then I'll divide by 2. So we get t equals to y plus 1 over 2. Now I'll go into my x, and no longer in terms of t, it'll strictly be in y and x. For t, I'll plug in y plus 1 over 2 squared. Doing a little simplification here. This is 1/4, right? 2 squared is 4 in the denominator, 1 over 4, and we get y plus 1. All right, now right away, squared, excuse me. I know I've confirmed this is in fact a parabola where it opened sideways and it shifted down 1 by that y plus 1 in there. So it looks something like this. Now, here, what I want to be careful with is, well, this is now, it's a parametrized curve. So it does have orientation. It has a sense of direction. How do I determine that? Well, I'm going to determine that by plugging in points, right? T, x, and y. All right, x of t, y of t. Right? And really, I just need 2, right? Because I know if I start at 0 from 1, then I know in what direction it's going as t is increasing, right? So I'm going to choose 0 and 1, and then I'm going to see what's happening in the curve, right, in the parametrization. So when t is 0, right, x, going back to the parametrize, is 0, and then y is -1. Okay? So we're down here. Now, as t progresses to 1, x is now 1, and y is also 1. So it goes somewhere over here if this is 1. All right, so now I've identified the direction, right? The curve is going in this direction. Okay, so just keep that in mind, right? When we have a parametrized curve, right, it's not just a rectangular graph, right? We also have a sense of direction, right? And that is how we can calculate the direction.